Devices, software, and cables that enables the exchange of information between them. Host devices are computers, servers, laptops, PDAs, or anything a person uses to access a network. Network devices are hubs, repeaters, bridges, switches, routers, and firewalls. Cables can be copper, fiber optic, or even wireless radio, which isn't really a cable but serves the same purpose. The applications used on a network include those that actually enable network connectivity, such as TCP/IP, those that test network links, such as ICMP, Internet Control Message Protocol, and end-user applications, such as email and FTP. There are thousands of networkable applications. We are concerned with a small number of them. A topology describes the layout of a network. You need to know several topologies for the exam. These are point-to-point, star, ring, bus, and mesh. A point-to-point topology involves two hosts or devices that are directly connected to each other and to nothing else. Anything sent by one can be received only by the other. Serial communication is usually point-to-point, but not always. A star topology is one in which one host or device has multiple connections to other hosts. This is sometimes called hub and spoke as well. In a star topology, if a host wants to send to another host, it must send traffic through the hub or central device. Ethernet, if using a hub or switch, and twisted pair cabling, is star-wired. A ring topology is created when one device is connected to the next one sequentially, with the last device being connected to the first. The actual devices don't necessarily form a circle, but the data moves in a logical circle. FDDI and token ring are examples of ring topologies. A bus topology uses a single coaxial cable to which hosts are attached at intervals. The term bus comes from an electrical bus, which is a point from which electrical power can be drawn from multiple connections. Ethernet that uses coaxial cable creates a bus topology. A full mesh is a topology with multiple point-to-point connections that connect each location to the others. The advantage is that you can send data directly from any location to any other location instead of having to send it through a central point. There are more options for sending if one of the connections fails. The disadvantages are that it is expensive and complex to implement a full mesh. You can compromise and build a partial mesh, which is when only some of the locations are connected to the other locations. LAN stands for Local Area Network. LANs are short-range, high-speed networks typically found in schools, offices, and more recently, homes. Over the years, there have been many types of LANs. Currently, Ethernet is king, and other than wireless technologies, is the only LAN technology you need to know for the CCNA exam. Ethernet is a family of implementations which have evolved into faster and more reliable solutions, all based on a common technology. Ethernet was pioneered by Digital Equipment Corporation, Intel, and Xerox and first published in 1980. The IEEE modified it and gave it the specification 802.3. The way Ethernet works is closely linked to its original connection type. A coaxial cable was used to join all the hosts together. This formed a segment. On a single segment, only one host could use the cable at a time. Because the wire was coaxial, with one positive conductor and one negative conductor, it created a single electrical circuit. This single circuit could be energized by only one host at a time, or a conflict would result as two hosts tried to talk at once and nothing got through. Much the same thing happens when you and a friend try to send at the same time using walkie-talkies. All that is heard is noise. This conflict is called a collision. CSMA-CD, Carrier Sense Multiple Access with Collision Detection, is the method Ethernet uses to deal with collisions. When a host wants to transmit, it first listens to the wire to see if anyone else is transmitting at that moment. If it is clear, it can transmit. If not, it will wait for the host that is transmitting to stop. Sometimes two hosts decide at the same instant that the wire is clear and collide with each other. When this happens, the hosts that were involved with the collision send a special jam signal that advises everyone on the segment of the collision. Then all hosts wait for a random period of time before they check the wire and try transmitting again. This wait time is tiny, a few millionths of a second, and is determined by the back-off algorithm. The back-off algorithm is a mathematical equation a host runs to come up with a random number. The theory is that if each host waits a different amount of time, the wire should be clear for all of them when they decide to transmit again. Any Ethernet segment that uses coaxial cable, 10-base-2 or 10-base-5, or a hub with twisted pair cabling, is a collision environment. Collisions have the effect of clogging up a network because they prevent data from being sent. The more hosts you have sharing a wire, and the more data they have to send, the worse it gets. A group of devices that are affected by one another's collisions is called a collision domain. As networks grew, it became necessary to break up collision domains so that there are fewer collisions in each one. Devices called bridges and switches did this. It is possible to eliminate collisions altogether if we can provide separate send and receive circuits. This is more like a telephone, which allows us to speak and hear at the same time, than a walkie-talkie. This requires 4 conductors, a positive and negative pair for each circuit. The use of twisted pair cabling, not coax, which has at least 4 conductors and more likely 8, allows us to create a full duplex connection with simultaneous send and receive circuits. Full duplex connections eliminate collisions because the host can now send and receive simultaneously. Full duplex connections eliminate collisions because the host can now send and receive simultaneously. This table summarizes some of the different Ethernet specifications, characteristics, and cable types. Modern Ethernet is fast, reliable, and collision-free if you set it up right. Speeds of up to 10 gigabits per second are possible with correct cabling. A wide area network, WAN, serves to interconnect 2 or more LANs. WAN technology is designed to extend network connectivity to much greater distances than any LAN technology is capable of. Most companies can't afford to build their own WAN, so it is usual to buy WAN service from a service provider. Service providers are in the business of building and selling WAN connectivity. They invest in the equipment, cabling, and training to build transcontinental networks for other businesses to rent. For the CCNA exam, you need to be familiar with 4 types of WAN connections and the protocols associated with them. There are 4 major WAN connection types: dedicated leased line connections, circuit switched connections, packet switched connections, and cell switched connections. A leased line refers to a connection that is installed and provisioned for the exclusive use of the customer. Essentially, when you order a leased line, you get your very own piece of wire from your location to the service provider's network. This is good because no other customer can affect your line, as can be the case with other WAN services. You have a lot of control over this circuit to do things such as quality of service and other traffic management. The downside is that a leased line is expensive and gets a lot more expensive if you need to connect to offices that are far apart. A leased line is typically a point-to-point connection from the head office to a branch office. So if you need to connect to multiple locations, you need multiple leased lines. Multiple leased lines get even more expensive. Leased line circuits typically run point-to-point protocol, PPP, high-level data link control protocol, HDLC, or possibly serial line internet protocol, SLIP. A circuit-switched WAN uses the phone company as the service provider, either with analog dial-up or digital ISDN connections. With circuit switching, if you need to connect to the remote LAN, a call is dialed and a circuit is established. The data is sent across the circuit, and the circuit is taken down when it is no longer needed. Circuit-switched WANs usually use PPP, HDLC, or SLIP, and they tend to be really slow, anywhere from 19.2K for analog dial-up to 128K for ISDN, using a basic rate interface. They can also get expensive because most contracts specify a pay-per-usage billing. Packet-switched WAN service allows you to connect to the provider's network in much the same way as a PC connects to a hub. When connected, your traffic is affected by other customers and theirs by you. This can be an issue sometimes, but it can be managed. The advantage of this shared bandwidth technology is that with a single physical connection from your router's serial ports, typically, you can establish virtual connections to many other locations around the world. So if you have a lot of branch offices and they are far away from the head office, a packet switch solution is a good idea. Packet switched circuits usually use frame relay or possibly X25. Cell switching is similar to packet switching. The difference is that with packet switch networks, the size of the unit of data being sent, called frames, is variable. Cell switched units, cells, are of a constant size. This makes dealing with heavy traffic loads easier and more efficient. Cell switch solutions, such as ATM, asynchronous transfer mode, tend to be big, fast, and robust. There has been a boom recently in the deployment of wireless networks for both LAN and WAN applications. The IEEE 802.11 Wireless Fidelity Standard, affectionately known as Wi-Fi, specifies a growing set of standards for short-range, high-speed wireless systems that are good for everything from mobile device connectivity to home media center systems. The advantages